Good morning, my dear children. This is Gayatri. Welcomes you all to the fourth session with the content. Are you all ready to listen? Okay. Till now, we have discussed the nature and properties of real numbers like 2, 3, -5, 3 by 5, root 2, root 3, etc. Do you think there exist other irrational numbers? Can you imagine other irrational numbers? Let us explore those numbers, recall the values 2 power 0, 2 power 1, 2 square, etc. Let us write these values in the form a power x is equal to b. That is, today we are going to learn the new concept, that is logarithms. What is logarithms? What is the definition of logarithms? Let a, b are real numbers where a not equal to 1, then a power x is equal to b. X is a logarithm of b to the base a. That is, a power x is equal to b implies x is equal to log b to the base a. Here we will write the short form of logarithm as log in further for solving the sums. You see here x is equal to log b to the base a. Here a base is a and b is the value of the a power x. Then x is nothing but the exponent. Now you see some more examples how to convert the exponential form to logarithmic form. 3 square, first one, 3 square is equal to 9. That implies log 9 to the base 3 is equal to 2. Second example, 2 cube is equal to 8. That implies log 8 to the base 2 is equal to 3. Now, how to convert logarithmic form to exponential form? First one, log 64 to the base 4 is equal to 3. That implies your base is 4, so 4 cube which is equal to 64. Second example, log 32 to the base 2 is equal to 5. That implies 2 power 5 is equal to 32. Now, the laws of logarithms. Like in exponents, how you have laws of logarithm, the same way you have here the laws of logarithms also. The first law of logarithm. Log a to the base x plus log b to the base x is equal to log ab to the base x. The second law of logarithm, that is log a to the base x minus log b to the base x is equal to logarithm of a by b to the base x. The third one is log a to the base a is equal to 1. That means logarithm of any number to the same base, its value is always 1, where a not equal to 1. Fourth one is logarithm of 1 to the base a is equal to 0. That means logarithm of unity to any base, its value is always 0. Now you see here some more examples of converting exponential to logarithm and logarithm to exponential, both vice versa. If y is equal to b power x, then x is equal to log y to the base b, where b not equal to 1. You see now the exponential forms here, y is equal to 2 power x. That implies x is equal to log y to the base 2. Second example, 2 power x is equal to 16. That means log 16 to the base 2 is equal to x. Its value is 4. Later on I will explain this is going to come. Now 3 power 4 is equal to 81. The logarithmic form of this is log 81 to the base 3 is equal to 4. So the 4 is missing here, for both are 4. And now see some of the rules which I already said, the laws of logarithms, which are similar in your exponents also. A power m into a power n, which is equal to a power m plus 1, m plus n. Similarly, in logarithmic rule here, log of mn is equal to log m plus log n. Now second exponent here, a power m by a power n is equal to a power m minus n. Logarithmic form you see here, logarithm of m by n is equal to log m minus log n. A power m whole power n is equal to a power mn log m power n is equal to n log m. Now see the fifth law of logarithm, that is log a power m to the base x, which is equal to m log a to the base x. The last one is a to the power of log n to the base a, its value is n. In general, the bases in the logarithms are always 10. So, whenever the base is not mentioned in the logarithm, it is to be considered as the base 10. Now, examples of the laws of logarithms. First one, log 15. How this is to be expanded using the first law of logarithm. Log 15. 15 can be written as 5 into 3. It means this is log AB. Log AB we can expand it as log A plus log B, that is log 5 plus log 3. Here you see the bases are not mentioned. That means you have to consider the base as 10. Next, second example, log of 2 by 5. This is in the same like second law of logarithm, that is log A by B. So, which is equal to log A minus log B, that is equal to log 2 minus log 5. Next, third one is log 5 to the base 5. That means its value is 1. I already said log a to the base a, which is equal to 1. The fourth one, logarithm of unity to any base, its value is always 0. So that's why log 1 to the base 3 is equal to 0. Next, log 8. How this is to be expanded? We can write 8 as 2 cube. Now, this is in fifth law of logarithm, that is log a power m to the base x, which is equal to m log a. So, the expansion of log 2 cube is 3 log 2. Now, sums based on laws of logarithms of different models from your textbook. The first one is expand 343 by 625. Log of 343 by 625 is equal to, this we have to use the law of logarithm, that is log a by b, which is equal to log a minus log b. So that is equal to log 343 minus log 625. That is equal to log 343, we can write as log 7 cube minus 625, we can write as 5 power 4. So when you write again the next law of logarithm, when you use it, you can write this as 3 log 7 minus 4 log 5, where log a power m is equal to m log a. Now the second model, that is log 1000. How this is to be expanded? 1000 can be written as 10 cube. So log 10 cube. And again, by using the law of logarithm, log a power m is equal to m log a, we can write this as log 3 log 10. Again, 10 can be written as 5 into 2. So again, 5 into 2 is in the form of log ab, that is equal to log a plus log b. So 3 into log 5 plus log 2. When you multiply 3 with log 5 and log 2 and remove the brackets, finally you will get the result as 3 log 5 plus 3 log 2. Next, find the values of log 3 to the base 81 and log 8 by 27 to the base 2 by 3, log root x to the base x, and log 0.01 to the base 10. These all models are very, very important for the examination point of view, children. These all are your textbook sums only. So some of them I'm explaining. The first one, log 3 to the base 81. Let log 3 to the base 81, you will assume it as suppose one variable x. Convert this into exponential form, that is 81 power x is equal to 3. 81 we can write it as 3 to the power of 4. So 3 power 4 whole power x is equal to 3. Here you use the law of exponent, a power m whole power n is equal to a power m into n. So 3 power 4x is equal to 3 power 1. That implies when bases are equal, we can equate the powers. So 4x is equal to 1, then x is equal to 1 by 4. The next one, second one, log 8 by 27 to the base 2 by 3. We'll assume it as some again variable x. Again convert it into exponential form. 2 by 3 whole power x is equal to 8 by 27. That implies 2 by 3 whole power x is equal to the exponential form of 8 by 27 is 2 by 3 whole cube. Once again, the bases are equal. You can equate the powers. So x is equal to 3. Now, the third one, log root x to the base x. We'll assume this to the variable a. Why I used here a? Because already in the question x variable is there. So I have used another variable a. So again convert this into exponential form. X power a is equal to root x. You can write root x as x to the power of 1 by 2. Once again the bases are equal. So equate the powers. Therefore x is equal a is equal to 1 by 2. The fourth one, let log 0.01 to the base 10 is equal to x. Convert into exponential form, 10 power x is equal to 0.01. So 10 power x is equal to, you can write 0.01 as 1 by 100. So 10 power x is equal to 10 power minus 2, because we can write 1 by 100 as 10 to the power of minus 2. By using the law of exponent, 1 by a power m is equal to a to the power of minus m. Again, the bases are equal, so equate the powers, therefore x is equal to minus 2. Now, the next model which we are going to learn here is express in single logarithm. The question is given here is 2 log 3 minus 3 log 2. This is the question. You have to express this question into the single logarithm. Let us see how the solution is given here. 3 log 2, we can write as log 2 cube by using the law m log a is equal to log a power m. Similarly, 2 log 3, we can write it as log 3 square by using the same law of logarithm. Then rewrite them here. Log 3 square minus log 2 cube. 3 square, its value is 9. 2 cube, its value is 8. So log 9 minus log 8. By using the law of logarithm here, log a minus log b is equal to logarithm of a by b. So finally we'll get it logarithm of 9 by 8. So we have converted the given question into a single logarithm, that is logarithm of 9 by 8. If you write again log 9 by 8, again if you go back to the steps, back steps, you'll be getting the question. Now second model, that is log 10 plus 2 log 3 minus log 2. How this is to be converted into a single logarithm. Log 10 plus log 3 square minus log 2. You all know that the 2 log 3 can be written as log 3 square. Now the first two parts, if you see here, they both are in the first law of logarithm, that is log a plus log b. Log a plus log b is logarithm of a into b, that is logarithm of 10 into 3 square minus log 2, that is logarithm of 10 into 3 square is 9, so 10 into 9 minus log 2. 10 into 9 is 90, so log 90 minus log 2. Once again, this is in the law of second law of logarithm, that is log a minus log b, that is equal to logarithm of a by b, that is equal to log 90 by 2, which is equal to log 45. So, my dear children, I hope you might have understood the definition of logarithm and laws of logarithms and how the laws of logarithms are to be used to solve the different model sums in this module. I hope you might have understood everything, children. You see here a very interesting picture is given over here. Log a rhythm. You see here a log, big log is there, and the rhythmic two drums are also given here. Children, let us tap the drums and make your mind into a very big log and put everything, whatever you learn, into that log. And I hope you will follow this, children. Thank you very much. Thank you, one and all.